Hi there, in this video I'm going to do a past exam question on coordinate geometry. So let's take a look at this question. Question number 4. The point A having coordinates -6, 4 and the point B having coordinates 8, -3 lie on the line L. In part A, find an equation for L in the form ax plus by plus c is equal to 0, where a, b and c are integers. So let's think about this problem. Let's get back to the paper and pen. So here are the 2 points, A and B, having these coordinates. To work out the equation of the line, first we need to work out the gradient of this line. So we need the gradient of this line containing the points. So to work out the gradient of the line L, so for gradient that's denoted by M, remember the formula. If you're given 2 points, to work out the gradient, the formula is y2 minus y1, so the difference in y coordinates, divided by x2 minus x1, so divided by the corresponding difference in x coordinates. So we need the gradient of AB, so I'm going to take my A as x1 and y1, and I'm going to call B x2, y2. So let me name these coordinates accordingly. And let me substitute the values into the formula. So y2 corresponds to -3, minus y1, that corresponds to 4, divided by x2 corresponds to 8, minus, and x1, that corresponds to -6. So if we simplify that, so -3 minus 4 is -7 in the numerator, divided by 8 minus -6 is 14, and 7 can cancel with 14, 7 goes into 14 twice to give us -half. So -half is the gradient of this line L. So we have the gradient -half, and our line passes through A and B. So to work out the equation of the line L, so the equation of the line L, we can use this formula for the line, y minus y1, that is equal to m into x minus x1. So if you're unaware about this formula, or the formula for working out the gradient, I have created videos on coordinate geometry, and I'll provide a link to these videos in the description below. Let's move on from there. Now, our line L passes through both points, so it doesn't matter which point you would regard as x1 and y1 in the formula. So you can take x1 and y1 to be the coordinate of A or the coordinate of B. It doesn't really matter, because this line L passes through both points. So regardless, I'm going to take my x on y1 to be -6, 4, but as I said, you can take it to be 8 and -3. You should get the same answer. M, on the other hand, M is the gradient, which we calculated as -half. So this is the data that we require. Let's put the data into the formula to give us y minus y1 is 4, that is equal to m is -half, into x minus, and x1 is -6. So this is what we have at the moment. Let's multiply the brackets. So on the left we'll have y minus 4, that is equal to -half times x is -half x, -half times minus of a -6 is -3. So be careful, minus times minus is minus, half of 6 is 3. Now if we go back to the question, we need our answer in the form ax plus by plus c equals 0, where a, b and c are integers. So back to the paper and pen. So let's get rid of the fractions. So let's multiply every term by 2 to get rid of this 2. 2 times y is 2y. -4 times 2 is -8. That is equal to -half times 2 is minus 1, so minus 1x. And 2 into minus 3, minus 6. And if I rearrange, if I take the minus x and the minus 6 to the left hand side, we're going to end up with x plus 2y minus 8 plus the 6 is minus 2. That is equal to 0. So that is the form that they want it in. That's the solution to part A. Let's go back to the screenshot. So we have another part to do, a part B. Part B is find the distance AB, giving your answer in the form k root 5, where k is an integer. Let's think about this problem. Let's go back to the paper and pen. So we have the coordinates of AB. That's been given to us as part of the question, and we need to find the distance AB. To work out the distance or the length, so to work out the distance or the length of AB, there is a formula, and it goes like this. It's the square root of, so it's square root of x1 minus x2 squared plus y1 minus y2 squared. So if you're unaware about this formula, I'll provide a link to a video whereby I go through examples applying these formulas in the description below. Now we need the length of AB, so going back to the question. A has coordinates minus 6 and 4, that is my x1, y1. B has coordinates 8 and minus 3, let's take that as x2, y2 again. So when I substitute in, I'll have the square root of, so square root of x1 is minus 6, minus x2 being 8, squared, so don't forget the squared, plus y1 corresponds to 4, minus y2, that corresponds to minus 3, close brackets, squared. So I've replaced the x1, y1 and x2, y2 using these coordinates for A and B straight into the formula to give me this step here. And all that we do now is simplify. So we need to simplify. So we have the square root of minus 6 minus 8. So minus 6 minus 8 is minus 14. So you have a minus 14 squared plus 4 minus minus 3 is 7. So plus 7 squared. So you have that term under the roots. When you simplify that term under the roots, that should give you the root of 245. And the root of 245, you can break that down to give us 7 root 5. So that should be your simplified form, the simplified surd, and that should be the solution to part B of this problem. So not only that is the solution to part B, that ends this question. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related problems, and I hope to see you again. Thank you.